record. And then we will dive right in. We have a lot to cover today. So let's start. Thank you everyone so much for coming to this event, Building the Future with LLMs, LangChain and Pinecone. We are so excited to have Harrison Chase here, the founder of LangChain, and of course, our superstar DA, James Briggs. For those of you who are unfamiliar with Pinecone, Pinecone is a vector database that makes it easy to build high-performance vector search applications. Now, before we dive on into the yummy content our hosts have prepared today, we have a few housekeeping rules. Number one, we ask that you use the chat for chat. Feel free to say hi, introduce yourself, let us know what you are building with Pinecone and LangChain. But when a question comes up, we ask that you add the question to the Q&A portion of the Zoom. The Q&A portion, not the chat. This helps us stay organized and reach as many questions as possible. So go ahead and put your questions there. If you miss something, no worries. We are recording this event and we will be sharing the event with you via email after the workshop. We also post all of our events on our YouTube channel and social media. So if you're not following and subscribing, I highly suggest you do so today. In that post-event email, we'll also include a survey. We ask that you take 30 seconds, give us some feedback. We're always trying to be better and bring you interesting content. Have questions after the event, or maybe we weren't able to reach your question, go ahead and add them to the topic in the Pinecone forums under the event title, Building the Future with LLMs, LangChain and Pinecone. You can access our forums via our support page. I will also add that link in the chat, so go ahead and feel free to. Now, without further ado, I'm going to go ahead and kick it to James. James, you want to take it away?
Great, thanks, Amanda. So I'll just share my screen. Okay, so I think everyone can see. Okay, so we'll just start. Let me get that up. Okay, so we're going to start with kind of like a very short history of NLP and so how it's progressed in the last, very recently, very quickly. So a little while back, with different tasks in NLP, you would have to actually use completely different models, and that would take a very long time to do. So imagine you wanted to do classification or you want to do question answering, you would need completely different models for these things. You would have to train these models on your particular domain, your particular data set. And that takes a lot of time, a lot of compute, a lot of resources, and in most cases, you probably don't just have a data set lying around for this. Then a little bit later, not so long ago, we saw the introduction of transformers and this idea of transfer learning in NLP. Now, the idea here is that a company like Google will train a big transform model. They will spend a lot of money doing that. And this transformer model can be thought of as kind of like a generalist. It can do a lot of things. It basically understands language very well. And then at the end of that transformer model, we add like a few layers, a few neural network layers, so that we kind of adapt the embeddings from that transform model to do a different task. And that required a lot less training, a lot less data, and we get way better results. And then NLP today it's pretty interesting. So you kind of just take a large language model, LLM, and it can, you basically just ask it to do these different things. You ask it to do classification, or you ask it to do question answering. And it's just kind of mind blowing that they can do that. But that's where we are today. Okay, so here there should be some screenshots showing a few things. So I'll just talk you through those. Large language models are a very big deal, and we've seen that very recently with ChatGPT, GPT-4 is just released, and a lot of other things. So ChatGPT was, as far as I'm aware, the fastest app to get to 100 million users, which is insane. Like, these have become, large language models have become very mainstream very quickly. But sometimes they do run into issues. Okay, so if I ask, this is GPT-4, which is, I think most of us would agree, probably one of the most advanced large language models out there today. If we ask it, how do I use the LLM chain in LangChain, right? So this is a specific question to LangChain, the library, which we'll talk about very soon. It starts talking about this blockchain-based platform that combines AI and language processing. And then it makes up this LangChain as a token system, and so on, right? So it's wrong, okay? Well, there is a blockchain-based platform, but then it's kind of just making up all these other things, and it's not what we were looking for. And that's a very typical model with these large language models. A very typical problem with large language models is that they hallucinate, so they can make things up and sound very convincing about it. And it's hard to keep the information they give us up to date. So that's two problems. But we're going to talk about that in a lot more detail later. For now, what I want to do is talk about the sort of huge growth and popularity of large language models. So, right now, they are literally changing the world. There is a huge number of startups and companies that are using large language models where they haven't really used machine learning or NLP before. Like, a huge number of companies that were not interested in this technology and now seeing the results from GPT-4, ChatGPT, from Google's Palm, Cohere, and they want to jump in on that, right? And LangChain it has found itself at the very center of this. So, I'll leave it to Harrison to talk a little bit more about what LangChain exactly is. But it really, like, when a company comes to try and use one of these technologies, the first thing is like, okay, how do we implement these? A lot of these companies don't necessarily have a ton of experience with these type of things. It's a very new space. And LangChain is kind of the solution to that. It makes using large language models in a lot of very interesting ways very easy. So, what is LangChain? For that, I will pass you over to Harrison.
Thanks, James, and also thanks, Amanda and Pinecone for having me here. I'm super excited to be chatting. So what is LangChain? The basic idea is that it's a framework for building applications with language models. And so, as James mentioned, language models are these new transformative technologies that are pretty easy for people to get started with and use because they sit behind APIs. They're generally pretty fast and pretty good at most things, although as James pointed out, they have a few flaws, which we'll talk about later. But even though they're generally easy to access right out of the box, in order to create some of the more interesting applications like chatbots, like doing generative question answering over your own documents, like summarization and using them in an agentic manner, there's a lot of tooling and infrastructure that still needs to be kind of put in place around them. And that's where LangChain comes in and provides that framework. And the design philosophy of LangChain, there's two kind of ways that we think about it. One is a bunch of modular components And so I think the next slide will go into that, but we have a bunch of modular components that are kind of focused on specific areas that hopefully you can use out of the box and use the abstractions that we have there to build things with those. But then we also have chains, which kind of are pre-built paths to use these modular components together. And so that makes it really easy to get started with a task out of the box. So just as like a simple example, we have like a generative question answering chain, which I think we'll actually talk about in detail later on. But that chain uses 4 or 5 of these different modular components, but we kind of like pre-organize them in this chain, so you don't have to think about any of that if you just want to get started super quickly. So those are kind of like the 2 main parts of LangChain. I think the next slide, James, if we want to go there, talks about the different components themselves. Yeah, so chains are kind of like the core idea of LangChain, and they're basically just components, and some of these components can be other chains strung together. The other more modular components that we have are prompt templates. So the language models take input as text and output text, but oftentimes the text string that goes in is desired to be constructed in a particular way. So it may combine a user question with some proprietary documents with some chat history. And so prompt templates we use as a way to take all those many sources of information and combine them into the single string that you can pass into the language model. LLMs are the next component. These are large language models like GPT-3, Bloom, the models that Cohere and now Anthropic and even Google are starting to offer. We offer kind of like a standard unified interface for interacting with all of them. So you can easily plug them in and interchange them and try one out versus another in your chains and see how the results vary. Another set of components that we offer are all around indexing. And so we're going to talk a lot more about this in the rest of the presentation. So I'll kind of skip over this a little bit, but these are just ways to interact with specific sources of data. Tools are another set of components. And so these are ways to interact with the outside world. So this can be like a search engine, a calculator, a Python REPL. We actually just added an integration today with Zapier, which has, I think, like 20,000 different sets of tools. And the idea is basically that you can use these tools in agents, which are the next abstraction that we have. And agents are language models which decide actions to take, and these actions are often using tools. And then basically they take this action, or they output text that says like, take this action. LangChain then like executes that action. LangChain observes the observation, feeds that back into the language model, and then the language model can decide what to do next. And the way that I like to distinguish chains from agents is that chains are kind of like preset steps that you should take, like do this, then this, then this. Agents are more non-deterministic. So it can take an action, and then based on the observation, it can decide to do one of many things. And then the last component that we have is memory. And this is just the basic idea of remembering kind of what's happened in previous interactions with the language models. So this can be short term, like what happened previously in the chat. This can be long term, like, you know, what did you do 3 days ago in your interactions with the language model. And yeah, so these are kind of like the core components of LangChain currently, and we're adding to these over time. I think, like, you know, the one thing that I really know is that it's super early in this space and it's moving super fast. So we're constantly adding to these and improving these as we see the need for them. I think probably next slide now, James. Yes, so we chatted about chains, and this is a nice diagram. It's really just hooking together those components that we saw before. And in particular, like one of the most popular chains, or one of the most necessary chains, which James actually alluded to earlier, is like the LLM chain. And that really just combines the idea of like a prompt template with an LLM. So, you know, the LLM interface is you take in a string and you output a string. And these strings are, they're just strings, right? There's not a lot of like type safety. There's not a lot of knowing what goes in or what goes out. And so I think the next slide is on prompt templates themselves. And so we can see why this is so useful. Yeah, so we can see here that, okay, so this is a nice diagram where you have some instructions up top. So the prompt templates are basically a format that add a lot of structure to this final string that you're outputting. And so if we take even a simple example of like doing question answering over context, we can already see that there's a few different components. So one, there's like the instructions up top. And so those basically tell the language model what to do. And you can, there's also now these new like chat-based language models that have specific places to put these instructions. And so there's some really interesting ways that we're thinking about around how to actually do instructions. But the basic idea is there's some instructions. There's then this placeholder for context. And this is external information that we can pull in from a variety of sources, like vector stores, like Pinecone. And so this is something that we're not hard coding into the prompt template, but that we are rather like getting each run, because this will depend on the question actually. And so that brings to the next section, which is the question. And so this is the this is input from the end user. And so this is also not known when we're kind of like constructing the prompt template, but we put a little placeholder for it and we'll format it in there. And then after that, we basically tell the language model, hey, start writing your answer there. And so prompt templates are a way to structure a lot of the input that's going to the model. So you know kind of like exactly what's going where and what's coming out. Little side note on something that's like very new that we're working on is the opposite of this. So structuring the output of the model. So again, the output of the model is just text, but we're working on some cool ideas to basically validate that it's in specific formats or that it passes kind of like specific conditions. The idea being to add some of this like type safety that you might get in programming languages to this language model, which is a new paradigm of programming languages in some ways. And so, yeah, next slide, probably good now, James. So I mentioned this a bit earlier. Agents are one of the most, I think, one of the most popular things in LangChain, and they're really popular because they can do some pretty like amazing things. The basic idea is you've got this language model at the middle, and you're using that as your core reasoning piece. And so it's hooked up to all these different tools. So you've got like a SQL database, a Python REPL, some like search engine. And then when a user question comes in, the language model itself decides which one it needs to use. It then like executes some input against that tool. It observes the output, and then it decides whether it needs to like try again, try a different tool, or it can just like return to the user. Yeah, it sounds like a pretty simple idea, but it's super powerful. And one of the big questions that I get is like, you know, how do you tell the LLM to like use the SQL here, or use the Python for this, and use the Google search for this? And the answer to that is pretty simple. You just tell it to in language. Yeah, it doesn't sound like it should be that easy, but a lot of these language models are really, really good at following instructions and understanding kind of like ambiguity. So, you know, you can say, hey, I have this Python REPL. You should use it when you want to like write and execute code. And it just kind of like knows to do that. And yeah, this understanding and this routing makes this like really powerful and really flexible. Next slide. So this is, yeah, so this is, so memory is a sneaky important thing to think about. And basically, the reason it's like so important is that I think the biggest like interface for using language models in a public facing way is ChatGPT. I think James was talking about the popularity of it. Besides the language model itself, they also have this aspect of like, I mean, it's a chatbot. It's got like chat history and conversation history. And that's not built into the model. That's actually something that you need to build around it. That's part of the framework around it. And so, you know, there was a recent release of like the ChatGPT API. And I think a common misperception that a lot of people had was that it would store the conversation in it already. And that's not actually true. It's a stateless kind of like API. So managing the memory falls to kind of developers outside, and that's what LangChain can help with. And so, like, why is this conversation so powerful? I think there's a lot more power in being able to ask like follow-up questions and just have a natural conversation with these things than if it's just like standalone questions. I think that's a pretty important UX and UI kind of like decision to make. That you know, the stuff the stuff that ChatGPT could do was always available. I think it was putting it in this chat interface, adding in this memory, the ability to ask follow-up questions, say like, hey, no, that was wrong, but try again. I think that unlocks a lot of value for users. And so I think this is a sneaky underappreciated, but very valuable component. Next slide, probably. And so, yeah, I think, the hope with building LangChain is that it really is a framework for building with language models. And so we've got these different components that we think are pretty useful for building applications. But one thing that we always want to be doing is refining them and listening again. It's like so early for building these applications, but we want LangChain to be the place to go. And so, we'd love. We love interacting with people in the Discord. We love building things. We love seeing what people build because we're just excited to be on this journey. And I think I'll pass it back to James to do the exciting deep dive on the main topic of this presentation.
Cool, thanks, Harrison. I want to go back to some of those issues that we saw at the very start of the slides. So there's a question about the LLM chain in LangChain. And this is the output from GPT-4, which is obviously, we expect it to be the very best at the moment. And we can see that it's talking about this blockchain-based decentralized AI language model, and that's not really what we're looking for. But the problem is that most of these models, their training data was cut off back in like 2021. So they have no idea about LangChain, or at least not the LangChain that we're talking about right now. But then we did something slightly different with this prompt. Now this is still going to GPT-4, and we're getting this output here. And you could also get this with GPT 3.5 as well. But you can see that we're getting this output. So, this is exactly what we want. This is taking us through the code, explaining how we actually use the LLM chain. And like, as far as I can see from looking at this, it has pretty much every step in there that we need to take. But we're still using the same language model. So, what is the difference between these two? The answer to that is retrievable augmentation. Okay, so the idea behind this is, on the left here we have our large language model, and it has a ton of knowledge that it learned during training, and it's incredibly good at giving us answers based on that knowledge, like really amazing. But the problem is that knowledge is somewhat limited. Although it's pretty broad, but it is still limited because it needs to fit within the large language model. And it's also not up to date. So, there are many things have happened since late 2021, but these large language models know nothing about that. And this becomes an even more serious issue when whatever your use case is relies on up-to-date information. Like if you're a news broadcaster or something where your information needs to be up to date, like large language models in their base form just won't work. So what we need is a way to allow the large language model to, based on a particular query, search through a particular subset of current world information or whatever information we feel it needs to know in order to do its job properly. And this is what we see with, all the recent chatbots. So, Google's Bard and Bing AI. This is kind of the approach they're doing. They have the chatbot, and the chatbot is kind of plugged into some sort of search where it can pull information from these different sources and give us what I think is much more meaningful information because it's up to date, and we can also source it so we know where this information is coming from. We don't have to just blindly rely or blindly trust that the large language model is not making something up. We can see where it's coming from. So this retrieval augmentation thing, let's talk a little bit, very high level, how that would work. So there's kind of two steps here. The first is getting that information from the world into what we call a vector database, which is called we call that indexing. And then the second step is actually using that. So taking our query, sending it to that vector database and returning relevant information. Now the indexing step is it's very simple. Okay, so we have our, our documents. This is what you can see over on the left, right? Let's imagine in this scenario that these are like the LangChain documentation, right? We want up-to-date information about using LangChain. So we go through all the documentation, we embed them with an embedding model, and then we send them over to the Pinecone vector database, where everything is stored, and it's stored as vectors, but we won't go into that right now. We'll cover it in a moment. Basically, it's in Pinecone, and at that point, we are able to access it using and feed that information into our large language model with this approach. So we take our query, how do I use the LLM chain in LangChain? We put that into an embedding model. Okay, that's the first step. That goes over to Pinecone. And this time, rather than indexing that question, we are querying with that. So we're saying, out of all the existing documents within Pinecone, which are the most relevant? And that returns a set of relevant context or relevant documents. And then what we do with those is feed them alongside the query into our large language model. Okay, so now that the large language model has the ability to get information that is up to date, or either up to date, or it's coming from like our internal docs, or it's focusing on a specific topic. And with that, obviously, we know which context to embed into the large language model, so we can also feed that back to the user as well and tell the user where they actually came from. Okay, so it's all good, but how does that vector database part work? I mean, we can basically think about it as searching by meaning. So what I mean by that is we represent meaning as vectors. Okay, so in this first example here, we have the word bank, but it's in a different context. So it has a different meaning, and therefore within like a vector representation, if you are representing these words as numbers, then they would kind of be in a different location within that vector space. With the bottom example, these two things, they don't contain the same words, but they do have the same meaning. So they should be together within that vector space. So in order to do that, in order to translate from human readable text into large language model readable vectors, you use what's called either an encoder, an embedding model, or a retrieval model. And they all mean the same thing. It's just different words for the same thing. So in this example, we can have like question and a relevant context or relevant piece of information. This is kind of what we're trying to do with the LangChain example, and we put them into the same vector space. And see another example of that here. And so what we would do is with one of these embedding models or encoder models, we would just take all of our documents, so the LangChain docs, feed them through the embedding model, and we would end up with this, which is just loads of vectors. We place them into Pinecone, and this is what we have. But then what we want to do is we want to search through this space. So we introduce our query, which gets encoded into this vector space using the same embedding model, like this. And then what we're basically going to do here is look at which of these vectors that we already put inside our vector database are the most similar, like the nearest to our query vector, right? So because that vector space is encoded by the model based on meaning, okay, so not based on words or anything like that, it's based on meaning, what we will find is when we pass that query vector in there, we return relevant pieces of information from our whatever it is we have indexed. So pairing embeddings with vector databases is what enables this semantic search. So search based on meaning. And I'll pass it over to Harrison, but essentially LangChain makes all this very easy. So Harrison, go and take it away.
Yeah, no, thanks, Jim. So basically all the components and all the sequences of steps that you mentioned, we have components for them in LangChain, and then we also have chains, which are predefined steps for them. So on the left with the ingestion part, there's in the diagrams, there's the documents, the embedding models, and then a vector database. And so all of those are abstractions that we have in LangChain. So we have document loaders that load text from files, from web pages, from Notion, from a bunch of different sources, and ingest them into a common format. And that format I'm just going to talk about briefly because I saw some questions where this might be relevant. Basically, as part of that format, there's the text, and then there's the metadata for that document or for that piece of text. So that metadata can be the source that it came from. It can be the page that it came from. And then also when we split these documents up, it can include like the relative position of that chunk of text to other pieces of text, because by the time it goes into the embedding model, we can't pass in a massive chunk of text. And even if you can, that probably wouldn't be the best idea, because you want to create these embeddings, these numerical representations for something that's like semantically meaningful. And so we chunk these documents up, and we can include in the metadata relevant pieces of information about where that chunk of data came from. So that's on the ingestion process. Then you've got the diagram on the right, which is how we use this. And so the general process here is, you've got a question that comes in, we throw this into an embedding model, we look up a bunch of documents, and then we pass this into a final LLM call. And this is, there's 3 or 4 different steps here. These are all abstracted away into a single chain in LangChain. While making it also like configurable. So you want to like swap out the embedding model that you use. Sure, that's easy. You want to use a different prompt to instruct it to return a response in Italian instead of English. Sure, that's easy. So this chain is configurable, but the end-to-end is a chain in LangChain. And there's actually several chains. So James, if you want to go to the next slide, there's actually a few different variants of chains that utilize this same idea. So there's vector DB question answering. And so this is basically the simplest version of this. And that's exactly what was on the slide before. Then you've got vector DB question answering with sources. And so this is where the source piece from the metadata comes into play. So when a language model is responding, one thing that's often very nice to do in order to fact check the language model or just inspire confidence is to return some information about like the source, where it came from. And so if you include that in the metadata of the document, you can actually ask the language model, hey, cite your sources. And now I can say like, I know this answer and it came from this specific page in the LangChain documentation. And you can even start to do even more things, like you can start to generate it in Markdown. So then you get a link to that page, or you can do a bunch of other things with that. And then the third variant is basically everything we've talked about so far right now is like stateless, kind of like, single question in, question out. As I talked about before, chat is a big part of this. And this is where memory comes in as well. And the interesting like subtlety here is that it comes down to like, what documents do you want to fetch? Or I guess there's 2 components. It's like, what do you want to pass into the prompt for the LLM to answer? And then what documents do you want to fetch? So on the what documents to fetch part, let's think about like a conversation. If I'm chatting with an AI assistant and I ask a follow-up question where I say like, could you explain that answer more? If I just embed, could you explain that answer more? That's super vague. It has no idea what the previous answer was referring to. It has no idea what it should be responding to. And so there it's useful to kind of like get some sense of what the previous conversation was, embed that and pick relevant documents for that. But at the same time, if I ask a completely separate question that has nothing to do with the previous question or answer, we don't want to be including the previous context, because that would just like add noise into what the final language model is deciding to respond. So this is a bit off slides, but just interesting. You know, like one thing that we have a chain for this is basically you combine the chat history with the follow-up question, and you get a single standalone question. And so if the follow-up question is something like, could you explain that more? The standalone question would be like, could you explain memory more? And so then it will know to look for documents that have to do with memory. While if it's something that's completely unrelated, it will just spit out the original question and embed that. And so then you get the relevant documents, and then you can pass that to the language model to answer, and it now has kind of like the most appropriate and the most relevant context. So those are kind of like the three main types of chains that utilize the same underlying abstractions of all this semantic search, retrieval augmented generation. That's it for this slide. I think James has a demo next.
Yes, that's right. Okay, cool. So let me pull that out. So I just want to very quickly show you kind of what the process would look like with this, with what we've just talked about. So you can also just follow, you can get access to this notebook. We'll leave a link to this in the slides, so you can follow along, or so that you can access it afterwards. But very quickly, we'll just take a look at a few of the key components that we're using here. So one of the parts that we mentioned was the ability to kind of process your documents with LangChain. So LangChain has a few different options for that. So a question that I see a lot is, how do you chunk your long pieces of text? With LangChain, it's super easy. You just do something like this, and there are obviously a lot of utilities for that. So we chunk all of our text into smaller chunks. We then use a embedding model, again through LangChain. We're using OpenAI's text embedding order 002 here. That will create all of our embeddings. And then we also initialize our Pinecone vector database. So we initialize our index there. We add all of our vectors to that. And then we are kind of left with, like, we have not so many, like 27.5 thousand vectors in there. So this is using a very small Wikipedia data set. Now, from there, we start using the vector store, the Pinecone vector store within LangChain. So we can, like, very quickly, we can just search, right? We can just retrieve relevant pieces of information. So we can ask a question and see that we're retrieving relevant information from Wikipedia with regards to a question, right? And we retrieve a few parts of this, okay? So I think we have like three documents there that are relevant to this question. With that, we can then take a large language model, okay, so using the GPT 3.5 here. Then we initialize this vector-DB QA chain. We pass in the large language model and our vector store, and then we just run, okay? And now what is happening is we are passing in our original query, our original question, and those documents that you saw as retrieved before. But the vector-DB QA class here is just handling all of it for us. Okay, so it just makes things really simple. And then it's just outputting a very more concise and better answer based on that information we got before. And then we also have the vector-DB QA with sources chain. This one's quite cool. So you have your question and you get your answer, and then it tells you where it got that information from. So where the sources were coming from, right? And then we haven't got the chat QA class in here. But yeah, I mean, just those two alone are really cool. And then obviously we can take that even further with the chat class as well. So with that, I think I'll pass over to Amanda for the Q&A.
Yes, it is Q&A time. So if you have questions, go ahead, add them to the Q&A portion of the chat. We have a lot already, so I'm going to share with you guys a link on the forums. If we don't get to your event, you can add them there. But let's dive on in. Chris is wondering, can you use LangChain to train embedding models on proprietary data? If not, how do you recommend to do that?
Yeah, so right now we don't do anything to do training of models, of embedding models or language models. What I recommend, but we hook into a bunch of different model providers, and so you can use those to train and then deploy models on proprietary data. So I think Hugging Face is probably the best and easiest example of this. They have, they have a lot of open source models on their hub. You can pretty easily kind of like fine tune them on your own data. And then we offer, I think we have, Hugging Face has a few different ways that you can interact with models. You can interact with them locally. You can interact with them via the inference endpoints. We have integrations for all of those with LangChain. So I think like one of the value adds that LangChain provides is this like generic interface that makes it easy to transition from OpenAI embeddings to Hugging Face embeddings. So we don't do it ourselves, but we hook into other people like Hugging Face that do.
Great, thank you. What is the most low-code approach to use LangChain? API-based mainly?
Yeah, we so we don't have a currently great low-code approach. I saw something on Twitter earlier this week that added a UI on top of LangChain. That would probably be the current best one out there. We're also yeah, we're thinking about this, but I think going back to like what we know and what we think it's so early in this space. And so we want to get a bit more confidence in some of the abstractions before exposing them in a low code manner. So yeah, I would check out, I think someone linked it in the chats. I think it's called like LangFlow. I think I would maybe check out that. Yeah, we currently do not offer anything ourselves for low code.
Chris says, LangChain is such a great library with a lot of useful components. It's available to everyone. Do you have thoughts on how you can use it to build something? Well, we talked about proprietary, but using LangChain beyond just using proprietary data.
Yeah, absolutely. I think there's two ways to kind of like build proprietary. Well, there's probably more, but I think there's two main ways for building kind of like proprietary and differentiated products. One is the data, which we've already talked about, and then one is basically the set of tools or the set of logic that you embed in your applications. And so I think like the LangChain chains and the primitives, the way that LangChain is built is designed to be used in kind of like scaffolding to create like complex kind of like chains, whether it's existing chains that are in there or whether it's you yourself combining these in like interesting ways. Because I think, yeah, like in terms of differentiation, in terms of making it hard for people to copy, like having a unique ordering of chains, having a unique ordering of prompts, all of that are ways to do that. And we hope that LangChain's kind of like modularity allows you to assemble like these complex things and build up some differentiation there.
Great. I know we talked about chunking a bit earlier, but can we just reiterate, what are the best methods for chunking? Number of sentences to use, for example, and do you add more context to each chunk? So when generating embeddings, some information is not lost.
Yeah, I think this is a super interesting question. I would also love to get James's take on this because I don't think there's a definitively kind of like right answer. I can definitely share kind of like my thoughts. I think I've noticed, and there's been a bunch of other people doing some really cool work around this as well. So I think Lance Martin on Twitter did some stuff comparing different chunking and embedding techniques. And I think it's still, one, it's an underexplored area. Two, we recently launched some like evaluation suites that do evaluation of whole chains. So not just the language model, but everything from the chunking to the embedding to the storage and the vector store. And so our goal is to use this to maybe get some more systematic answers to these questions, because I think this question is a really good one. As for what I would actually like recommend now, I think somewhere around like 3 sentences is pretty valid. And then I think, yeah, definitely the idea of having some overlap between chunks is important. I think like the main, like what are the considerations, right? I think there's one consideration where you want to make sure that you have the appropriate amount of context in each chunk. And so that's where something like doing some overlap makes it easy to kind of like have that. Another consideration is you don't want them to be too big though, because the more like narrow and focused the chunk is, then the better you can actually like when you're looking up relevant things, you can figure out like this piece of information is most relevant for this. So I think it's a balance to strike. I've also, I mean, I might release something tomorrow. I think there's some really interesting work that you can do here around balancing those two things. And this is also where like the metadata comes into play, because you can get more than just a single chunk if you want. You can get other relevant chunks based on like the metadata. And so this is maybe a good prompt, so to speak, for me to go add some stuff in LangChain. So thanks, Chris, for this question. I think there's a lot of nuance here. Oh, the last thing I'd actually add here as well, there's so much nuance in this topic, but like the right chunking can absolutely depend on the type of text that you're working with. So by default, we have like the recursive text character text splitter, and that basically assumes it's working on generic pieces of text. It splits the chunk first by paragraphs, or first by double new lines, then by single new lines, then by spaces, stuff like that. And the idea there is to basically try to keep as much semantic meaning in each chunk, so like paragraphs and stuff like that. But we also have a markdown text splitter, and this splits on like markdown specific tokens. Like it has like a header token, or it has like the hashtag which you use for like header 1, 2 hashtags for like header 2, stuff for that. And then we also have a Python specific text splitter that splits, and this is for like splitting on like Python code files. So this splits on like classes, and then within methods and classes and stuff like that. So I think like, yeah, the types of text splitter are another like variable that you can play with. I'd love to get more of those in LangChain. There's actually both the Markdown and the Python work the similar way, where you just define a list of like tokens that are special for that type of text. And so I think it should be pretty easy to add some more specialized ones in there. I would, yeah, I'd love to get a lot of that. And I think this is a super nuanced topic. Lots more to be dived into here. Would love PRs, ideas, anything to kind of like help improve this. There's a lot there.
James, do you want to add to that as well? Your YouTube, one of your YouTube videos is quoted in the comments of this question too.
So I just lost connection briefly. Can you repeat the question?
Best methods for chunking.
Okay. Yeah, I mean, beyond what Harrison went through to start, I don't think I have a huge amount to add to it. My general rule of thumb is kind of like roughly paragraph size, and just from a human perspective, does what is covered in that chunk actually make sense? That should give you a good indication as to whether the embedding model is going to embed something meaningful there, and whether the generative model after can actually take something from that. And yeah, also just always include those overlaps.
Great, thank you. And Harrison, I like that you got essentially some homework out of that. Next question. So is there a native way of building these components into non-serial chains? Chains are currently linear, and there is no clear way of building control flow and loops with LangChain. Are there parallel concurrent chains possible?
So for the non-linear stuff, we mostly use agents for that, basically. And so agents are not only are they non-linear, they're also like non-deterministic. So I think we use them for that. I think there's a middle ground where you have some like where you have like some for loops or something like that, and those are maybe, or I guess like branching ones and then parallelized stuff. I think those might be more in the aspect of like parallel chains that get run. There's nothing in there currently. We did recently add kind of like async support, and so that should make some of this easier. But there's nothing in that currently. Yeah, I think like for some of the obvious places, so like we have like some like map reduce question answering chains which do the same language model prediction over multiple different chunks. Like we do that there. So like we do, and in fact, we actually do it, we batch calls to the language model providers themselves, which actually takes advantage of some of the things on their end as well. So for the like really obvious places, we have that built in, but we don't have like a systematic way of defining them and building them that way.
Thank you, Harrison. James, are you still with us? I saw in the comments you are taking care of a scorpion. This is a webinar first.
Yeah, I'm here.
When is it appropriate to use dense versus sparse vectors when on queries with n words when n to 2, and sparse vectors when we have a query with 1 or 2 words?
So where's n words when n is greater than 2 and sparse? So I mean, in this case, I don't know if I would use sparse because there isn't really that much information there, but then it's also kind of hard to use dense embedding models. Like you would probably have to go with like a more word level embedding model when you have something that's very small. Yeah, generally speaking, you want to use sparse and dense together, or the best place to use sparse and dense is with dense by itself. You can get really good performance and you get to kind of include that semantic meaning, but they kind of struggle when it's a out of the main data set. Whereas with sparse, they generalize very well, but they are generally limited to like word matching, and the performance is very like you're not going to get much better performance. You can't like train a model or anything like that. So using sparse and dense together is good for either like multimodal when you're going text and image and you kind of like place one of like the text and the sparse and the image and the dense vectors, or when you want to do a semantic search, but then you also want to cover slightly out of domain queries or out of domain documents with the sparse vectors. That's generally how I would recommend using them. But then obviously it's a completely different thing when you're doing very small sense, like 1 or 2 words. So then you kind of want to look at word level embeddings, which is something like word spec.
Thank you, and we're all sending good vibes for your safety, James. We have another question. What would be the best way to control/evaluate cost when using LangChain to query OpenAI's APIs? Example, using embeddings for building a Q&A bot via existing knowledge base.
Yeah, so we have a callback handler that tracks the tokens used. We haven't integrated like the cost into that equation yet because yeah, OpenAI sometimes changes them and stuff like that, but you can easily track like tokens with the callback handler, and then depending on the model that you're using, the cost will change a bit. Yeah, I think we'll definitely consider adding some, like, I've heard this question a bunch, so we'll definitely consider adding some kind of like cost factor into that, but right now it's just token tracking that we support.
Great. So do you guys intend to integrate some guardrails concepts in LangChain besides output parsing?
Yes, there's actually been a PR open for I think like 2 months that I haven't had time to merge in, that adds a lot of ideas around. So I guess, yeah, explaining for folks, like output parsing is basically, you've got text, it's now got some structure to it, like it should be like a JSON blob or something like that. And so that's basically like ensuring that that's the case. And so like more things that we're going to add there are basically, okay, like, you know, some concept of like retries and fixing that. And then there's also concepts of like one of the things that's gone kind of viral is like the idea of like prompt stealing and stuff, where you get the language model to like spit out its own prompts. And so we can add some guards there that basically attempt to block that, or attempt to make that easier by looking at the output. And it's not perfect, obviously, because there's a lot of you can go down a rabbit hole pretty quickly. But yes, we will absolutely add guardrails concepts into LangChain.
What are the most popular embedding tools used with LangChain? What are some of the pros and cons of them?
I'm not entirely sure what is meant by embedding tools. I'm going to interpret this as like different embedding providers, or maybe it means text splitters. I think those are kind of like the two main tools that are used when calculating embeddings. For the embedding providers, I mean, I think the most commonly used ones like OpenAI, just because I think most people are still on that. I actually think like the difference between them and other models in embeddings actually isn't that big. Like I would love to see more like open source, kind of like easy to use embeddings here. I think obviously the GPT-4 models are amazing at text generation, and I think they are differentiated there. But for embeddings, people use them because it's very easy, it's very fast, it's pretty cheap. But I think there realistically could be some good alternatives there on the embedding front. For the text splitting stuff, I think like the recursive text splitter is my like go-to. I think it kind of just like works out of the box. You don't have to think about what characters to split on. It has some like overlap in it built in as default. It has like a semi-reasonable chunk size as default. And so I think that's the most popular one / the one I would recommend.
Great. And this came up, Harrison, during your agents slide. Joydeep wants to know, is LangChain is injecting the instruction? So let me know if that makes sense or not.
LangChain is injecting the instruction. We are, so for agents, oh, was this maybe for the instruction for the prompt template as well for the question answering thing? Or was it?
Think so.
Okay.
Yeah.
Yeah. So okay. So the instruction and specifically the prompt. That's a really good question. So by default, LangChain has prompt templates that we use that we think are pretty good for accomplishing a task. We also make it super easy for you to swap them out for your own prompt templates or your own instructions. And so if you want to change the instruction, you swap out the prompt template. But by default, we have a default prompt with a default instruction that we use to make it really easy to get started out of the box.
Great. So we are nearly at time. And there are so many more questions, but I want to be respectful of everyone's time. Harrison, you ran through those questions like a champ. So we appreciate that. We posted it in the chat, but if you have questions after this event, if we weren't able to get to your questions, we have created space in our forums. I will also send that link out in our follow-up where you will receive the slides and the event recording. You'll get all the things, I promise. So feel free to ask your questions and give any feedback there. Thank you guys so much for this event. You killed it. We appreciate all of you attending, and I like to end things with a gratuitous round of applause. So thank you, everybody. And we'll follow up. Thanks, guys.
Thank you.
Thank you. Bye.